Very much, and thank you all for coming inside on a glorious day. It's always a pleasure to be in Blue Mountain. This was the very first place I ever came in the Adirondacks many years ago, and so many, every time I'm here, so many kinds of old friends and ghosts of old friends appear, and it's wonderful to think about. The very first person I ever met in the Adirondacks was Brother Blanchard, who some of you will remember, and Ann and Evelyn, and all the crew at Blue Mountain Center, and then just on and on and on. I can't think of any town in America where I have a higher percentage of the population as dear friends. And that says something, of course, about the size of the population, but also about its great quality. And of course, the museum is a big part of that. And it was one of the places when I was trying to figure out kind of where I was, to orient myself once I kind of impetuously moved to the Adirondacks many years ago as a young man. It was one of the places that really helped me understand in context where I was. And so I'm very grateful, Jerry, for the invitation to be here, and therefore feel all the guiltier for bringing you A, inside on the prettiest day of the year, and then B, whenever I've got people in an audience, I'm always reminded that my essential role in the world is to be a professional bummer-outer of people, and for that I apologize in advance. I feel guiltier than usual. I'll try to end on a hopeful note, but we will go through the valley for a minute first, because there's really no way around it, given where we now are. Look, I wrote the first book for a non-scientific audience about climate change. It came out 22 years ago in 1989, a book called The End of Nature. And in fact, it was no coincidence that I wrote it living here in the Adirondacks. I don't think I could have written it otherwise. It was against the backdrop of this amazing recovered wilderness, the greatest ecological restoration project on the planet, a place that I was deeply in love with, that the sadness of this new, even larger plague of climate change was most apparent and powerful. And frankly, we knew most of what we needed to know 22 years ago about global warming. We knew the essentials. You burn coal and gas and oil, you put carbon dioxide into the atmosphere, and the molecular structure of carbon dioxide traps heat that would otherwise radiate back out to space. Those are the essentials, and they're neither controversial nor complicated. The only thing we really didn't know 22 years ago was how quickly this was going to pinch and how hard. And the story of the last 2 decades is that it's pinching considerably harder and considerably faster than we had thought, even in our kind of worst imaginings 22 years ago. We didn't understand, in a sense, how finely balanced the planet was. And so the developments of the last few years have taken everyone, even the scientists most engrossed in this study, somewhat by surprise. I'm not going to bother listing the endless kind of changes underway in the world. That's much of what my last book, a book called Earth, spelled oddly, Earth with 2 A's, and spelled that way just to imply that we were already living on a fundamentally different planet than the one we were born on. I'm not going to bother reciting all those proofs. I'll just talk about what's happened in the kind of 18 months since that book came out, since it provides more than ample measure of what is going on. 2010 was the warmest year for which we have records on this planet. 19 nations set new all-time temperature records, itself a new record. Some of those records were almost unbelievable. We were on the phone one day last year with our organizing crew in Pakistan. It was right about a year ago. It was in July or August last year, and one of them said, "It's very hot here today," which I was surprised to hear him say, because it's always hot in Pakistan in the middle of the summer, and you wouldn't think to remark on it. He said, "No, it's really hot here today.
we just set the new all-time Asia temperature record, 129 degrees. Like, okay, that's indeed hot. I mean, Johnsburg, where I come from in Warren County, I mean, I don't think it's ever gotten to 100 degrees, but if it ever got close, you know, rest assured we would be bitching and moaning a lot. Add 30 degrees to that, and you know, for 98% of Pakistanis, subtract any air conditioning you might have, and that's, you know, what people's reality was like. And of course, once it gets that hot, all kinds of things start to happen. Among other things, everything frozen on Earth starts to melt, and it's melting very quickly. The Earth's cryosphere, its frozen portions, are in rapid retreat. You can see it most easily in sea ice in the Arctic. You remember those first pictures that came back from Apollo 8 of the Earth, you know, our first kind of view of the Earth as a whole? Those pictures are as out of date as my high school yearbook picture. There's about 40% less ice up there than there was in the late 60s, and about 25% less ice than there was in 2006. So that melt is accelerating, and as of right now, we're on a record pace again this year. But things are happening in places much closer to people. One of the things, of course, that happens when you warm things up is you get a more parched and arid planet in dry places. And we've seen spectacular drought. You'll recall those pictures from last summer in Russia of an epic heat wave and epic fires. It had never reached 100 degrees in Moscow in 250 years of record keeping, but it was above that level for about 8 days at the beginning of August last year. The drought was so widespread that the Kremlin panicked and ceased the export of all grain to the rest of the world, turned around ships and train cars and things. Now, that mattered because Russia's the third biggest grain exporter in the planet in a normal year, and the price of corn and wheat immediately went up 70, 80%. And it's stuck there pretty much ever since. The price of food is incredibly high. Now, where we are, that makes some difference, but not that much, because if you go buy a box of cornflakes or something, the price of corn really is only about, well, you pay more for the box than you do for the corn. And, you know, so it doesn't make quite the same difference as if you have to go and buy cornmeal every day to make tortillas. And then if you do, if the price goes up 70%, you generally eat considerably less than you want. And that's what's going on. The number of hungry people in the world is steadily on the rise again after some years of shrinking. We've seen similar drought, of course, in many other places. At the moment, most powerfully in the southwestern part of the U.S., stuck in an epic drought. Texas, parts of Oklahoma, it's drier than it was during the Dust Bowl. Drought just off the charts. Painful to see. You know, cattle and wildlife unable to cope with the shortage of fodder. A pretty desperate situation in many places. But it's not only, of course, drought. Once that water evaporates into the atmosphere, it's going to come down someplace or another in the form of rain. The atmosphere in general is about 4% wetter than it was 40 years ago because warm air holds more water vapor than cold. That's a very, very, very large change in a basic physical phenomenon. And what it means is that we have loaded the dice for downpour and deluge and flood, and place after place is, you know, in that great celestial dice game crapping out. Most painfully probably last year of all the great flood events, the one in Australia that you saw and so on. Right about this time last year, first week of August, the highlands in Pakistan, up by the Khyber Pass, an area that normally receives about 3 feet of rain in a year, got about 12 feet of rain in a week, in a just absolutely epic downpour. That caused the Indus River, the main river in Pakistan, to swell to the point where about a quarter of the country was underwater by the end of August. There's still, well, as of about 6 weeks ago, there were still about 4 million homeless people, the Red Cross said, as a result of that flood. And you get some sense, of course, of what that feels like when you look around our own country this year. after record snowfall, which is what happens when you have record rainfall, but it's below 32 degrees, and the melt that came with it, we then had record rains across much of the Mississippi Basin and the Missouri Basin this spring, and of course that prompted record volumes of water to flow down those rivers with all the broken levees and displaced people and things that went with it. And of course, in the North Country, we got some sense of that too this year. That epic flooding up in Essex County and in other parts of the park and all around Lake Champlain. We have records in Lake Champlain going back more than 250 years. It had never gotten even within a foot of as high as it was at high water mark this spring. And it stayed there at 103 feet week after week after week as one series of storms after another just continued to pound water down into the lake with remarkable results. Here's the thing I want to get across to you all. Everything that I'm describing happens when you increase the temperature of the planet about 1 degree. That's how much we've increased it so far. About 3/4 of a watt per square meter of the Earth's surface extra solar energy retained. What the climatologists tell us is that unless we get our act together very quickly, by getting our act together, I mean getting off fossil fuel far more quickly than any government on the planet is currently planning to do it. Unless we do that, they say we're looking at 4 or 5 degrees total warming before the century is out. That's not some outlier or extreme case. That's the middle case conservative estimate of what we're looking at. If 1 degree is enough to melt the Arctic and cause the kind of havoc I've been describing, we would be fools to find out what 4 or 5 degrees will do. But fools is what we will be unless we act very quickly, because there is an immense amount of momentum built into this system. And if we wait for that temperature rise to manifest or any other thing like it, it'll be far too late to do anything about it. There's about a 40-year time lag between the emission of carbon and its real heat-trapping effects, and that's the cycle that we're already working against. It's too late to stop global warming. We've already warmed the planet a degree. There's at least another degree in the pipeline from carbon we've already emitted. Now we're trying desperately, some of us, to figure out how we're going to hold it as close to that as we can and give ourselves a miserable century, but not a completely impossible one. Those are the possibilities. And the good news, such as it is that we know pretty well the outlines of this problem. The scientific method has worked enormously well. It's taken a very difficult problem in physics and chemistry, this atmospheric physics and chemistry, and in the course of a decade or two managed to really crunch it, to really understand what's going on. To the point where 3 years ago, our most important climatologist, Jim Hansen and his team at NASA, gave us the kind of bottom line number for this planet, the most important number we have. They wrote a paper saying we now know enough about, both on real-time observations of things like Arctic melt and based on our ever-growing library of paleoclimatic observation, ancient climate observation based on analysis of deep ice cores and things. We now know enough to say how much carbon in the atmosphere is too much. And what they said was, and I'll see if I can quote it for you, any value for carbon, CO2 in the atmosphere greater than 350 parts per million is not compatible with the planet on which civilization developed and to which life on Earth is adapted.